Homework 3.3 is our final transformations homework. Hopefully you're getting pretty good at these. The first set all uses the same original function, and it does different transformations on it. I'm only going to help with a few of them. The first I'm going to look at is f of 2x. So f of 2x has a horizontal compression by a factor of 2. And so what that means is every single x value is going to get compressed by a factor of 2. The way I like to think about it is that since c equals 2, the x values get divided by 2. They get divided by what they used to be. So this point is going to get horizontally compressed by a factor of 2, so instead of being at x equals 1, it'll be x equals 1/2. This point, instead of being at x equals 2, will get divided by 2 and be at x equals 1. This is at x equals 1, 2, 3, so it'll be at 1.5. This point is at x equals 5, it'll be at x equals 2.5. And so we end up with this function that looks like this, and you can see quite clearly it got horizontally compressed, and this is the new function. What's going on here is that if you plug in any of the new values into g of x, like let's say you plug in g of x, if you plug in 1 into g of x, well, if you plug in 1, it says you do f of 2. Well, f of 2 is 2, so g of 1 is 2. It changes the x values to be horizontally compressed. I'll give you a quick reminder on this last one. It asks you to find f inverse of x, and the way you find f inverse of x is by switching all the x and y values. So take all the x and y values, switch them, and you should get a nice f inverse of x. And remember that your answer should be the original one reflected across the line y equals x. On the back, I'll do a few of them with you. The first is d, y equals square root of x plus 2. There's only one translation. It gets translated 2 units up. Didn't get translated to the right. And the original point for a square root, the vertex is at 0, 0, so now it'll be at 0, 2. Square root functions, normally we can do square root of 1 is 1, square root of 4 is 2. Here, when we do square root of 1 is 1, it'll get vertically compressed by a factor of 1/2. So square root of 1 is 1, half of that is 1/2. The next easy number to do the square root of is square root of 4. So square root of 1, 2, 3, 4, square root of 4 is 2, but we have to do half of that, which is only 1. Square root of 9 is 3, but half of that is 1.5. And so we get this pretty vertically compressed square root function. It's growing very slowly, and that's what it looks like. Let's do e. E is 2 to the negative x, and remember that a negative inside of the function, here we've got f of negative x. This is, the base function was 2 to the x, it's f of negative x, and this is a reflection across the y-axis. So the important point for exponentials is 0, 1, and there's an asymptote at y equals 0. Normally, 2 to the 1 power would be 2. That got reflected. The reason this works is because when x is negative 1, negative negative 1 is positive 1, so it'll be doing 2 to the 1 power. When x is negative 2, it'll be negative negative 2, which is positive 2. 2 squared is 4. And that's the reflection from when x is 2. Normally it would look like this. So we get these, the constant multiplier going this way. And over here, normally when we go backwards, 2 to the negative 1 is 1/2. Now that point will be on the right side. And the reason is because when x is 1, negative 1 is negative 1. 2 to the negative 1 means you divide by 2, and it's 1/2. 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8. And we get this nice reflection across the line x equals 0, or the y-axis. The last thing I'm going to look at here, and I'm not going to do it for you, but I will give you a hint, is This is a transformation we have not learned about, and that's fine. And this is a pre-AP class. You've got to be able to think and apply things to new situations. The parent function is obviously y equals x cubed, and I'm going to graph that for you here. We know 2 cubed is 8, negative 1 cubed is negative 1, negative 2 cubed is negative 8. This is our parent function. The transformation that's happening to it is we are doing the absolute value of this function. So let's just think to ourselves, what does that transformation do? The absolute value of something takes all the y values, and instead of them being, if they were positive, it leaves them alone, and if they were negative, it makes them positive. So here we have some positive y values, and it's going to leave, this transformation isn't going to do anything to them because the absolute value of 8 is still 8. But on this negative side, when you do the absolute value of negative 8, that will change the value. I'll leave it to you to graph the rest of it, but I think you can figure it out.